All right, we are doing our lesson. This is lesson 10 from chapter 1. And first, we're going to start off with a little review. Go ahead and pause and try these first 5 problems, and then unpause, and I'll explain them to you and see how you did. Ready, set, go. All right, we are back. So let's estimate. Estimate to the nearest whole number. All right, so we don't have to get very specific. We just got to get in the ballpark. We're going to go with square root of 39. Well, I think square root of 39 would fit in here. And since 39, square root of 39 is 3 away from 36, but 10 away from 49, the square root of 49, I'm guessing the answer to square root of 39 would be closer to 6. All right, so that equals approximately 6. That's the closest integer. All right, next one. Square root of 102. Square root of 102. Well, let's use our little tool here. And square root of 102 is going to be somewhere in here. And 102 is closer to 100 than to 121. So we're going to say the square root of 102 is probably closer to 10. All right, so that's approximately equal to 10. Next, now the decimal here is going to try to throw you off, but you don't have to get confused. All right, because 71.3 is still just in between 64 and 81. All right, 71 is 10 away from 81, right? But only 7-ish away. So it's going to be closer to the 64, right? 71.3 is going to be closer to the 64 than it is to the 81. So the answer is going to be closer to 8 than 9. All right, so that one is, oops, I put equals. I should put approximately equal to 8. All right, hopefully you're cruising on this. You're doing okay. Another decimal. We're going to get an approximation for, so 25.9. Let's find where we would put that. Wow, well, that's going to fit right in there, and that's very, very close to 25. So I'm guessing the actual square root of 25.9 is going to be very, very close to 5. So we're going to put that. Now this next one takes it a bit further. It asks you to give 2 numbers that would have square roots between 9 and 10. All right, well, how did you go about this? All right, so if the answers to the square roots are 9 and 10, that means the numbers that you're choosing have to be somewhere in this range between 81 and 100. Okay, so for instance, the square root of 82, or the square root of 83, or the square root of 84, or the square root of, I think you get the point, all the way up to the square root of 99. Those are all possibilities. You could have gotten crazy and done like 84.3, but all these are in between the square root of 81 and the square root of 100, because that one equals 10, this one equals 9. So all of these square roots, if we got all those answers, they'd give us weird square roots, but with lots of decimal places, infinite actually, they're all going to be in the range. The answers are all going to be in the range between 9 and 10. All right, let's go to our next screen. Check the answers. These are the ones that we just agreed on. All right, and we're going to today ask the question, why is it helpful to write numbers in different ways? This is kind of the whole chapter essential question. For instance, we wrote numbers in scientific notation. Why is it helpful to do that? It's to shorten very, very long numbers. All right. Common Core state standards, we can rush through that. All right, those are for me to make sure that I am instructing you on what you need to know. Today, we will classify numbers. We're going to put them into their categories of what types of numbers they are, and we're going to compare and order real numbers. All right, today our vocab is irrational numbers and real numbers. You see irrational, and that's compared to rational. Right? So if rational are numbers that can be written as fractions, irrational are just the opposite, numbers that cannot be written as fractions. And then real numbers, they're just the collection of all the rational numbers and all the irrational numbers put together. Makes the real number set. Moving along, here we go. Write down these two definitions in your notes, rational numbers and irrational numbers. I also have something to add for irrational. Pause, write it down, and then listen up. So we're back. Irrational numbers cannot be expressed as a ratio, but they also have some other important characteristics to know. They are non-repeating and non-terminating. So they don't just end in zeros. They keep going on forever, but they never have a repeating pattern. So you can see the square root of 2 is just like that. There's no pattern. But also another important number is pi, because that goes 3.14159 ... Goes on forever and never repeats. That is an irrational number because it's non-repeating and non-terminating, and you can't write it as a ratio. Next. Classifying numbers, fun times. Who's a big soccer fan out there? I know I am. Here we go. I wish I had this many goals to score on in my backyard. Well, let me ask you this question. If you were to score in this small goal in here, would you also have scored on all of the other goals? All right, so you shoot it in the middle one. Oh, up a 90, what a goal. Okay, you shoot it in there, but it also went across the line in this goal, and this goal, and this goal, and this goal, right? So I actually scored 5 goals at once. That'd be nice. All right. So that's how it's going to work with classifying numbers. All right. We're going to start with this smallest goal being kind of a natural numbers. All right, that's our first classification, our most specific type of number that we're going to learn about today. And that's the numbers 1, 2, 3, 4, ... on and on. All our whole numbers, but not including 0. All right, our second goal is going to be our whole numbers. And that's all the numbers that are whole, including 0. ... All right, our next goal is going to be integers. And that are, here, I'm going to write it here so I have a little more space. All right, that is -3. Oops, sorry. I should write it like this. That's going to be 0 and 1, 2, 3, right? ... All of our whole numbers, but also including all of their opposites. So -1, -2, -3, ... Okay? All right, so we're getting kind of more and more general, like a bigger group of numbers. And finally, we have the most general, which is rational numbers. All right, rational numbers. So those are all the numbers we can write as fractions. All right, so is an integer also in the rational goal? All right, so let's say the number -3. If I shoot a ball labeled -3, all right, that would fly into that goal. Yes, what a goal. But it would also be inside of the rational numbers goal. So when we categorize or classify the number -3, we would call it an integer, but we'd also call it a rational number. All right? So it depends on which goal you would shoot it on, and then it could have more than one name or classification. All right? So let's try one more number while we're looking at the goals here. If, let's say, I chose the number 0. All right. Which goal would you shoot it in? And after you scored, which other goals would it be inside? I guess another question is, which goal wouldn't it be inside? Okay, so if I took that ball and shot it, I would shoot it in the whole numbers. It's like a donut. Okay, that ball with a 0 on it would go to the whole number goal. All right, and which other goals would it be in? It's a whole number. It's also an integer. It's also an integer. All right, and it's also a rational number. But it's not a natural number. All right, it's not a natural number. Okay, how about the number, let's say, if I had a ball that had the number 17 on it. All right, which goal would that be scored in? And then because it was scored in that goal, which other goals would it be in, or which other classifications would it have? All right, so the ball with a 17 on it would go in natural. So it's natural. So therefore it's also whole, it's also an integer, and it's also a rational number. Okay, last one. What if I have a number like this? 1/2. All right, which goal would that be scored in? Could I kick it in the natural goal? No. Could I kick in the whole numbers? No. Could I kick it in the integers? No. I would have to aim for this outer little section here. I'd have to be pretty good to hit it just in that little range there, in that, that outer goal, because it's just rational. You wouldn't want to put it in the integer, whole number, or natural goals. So you just have to kick it in that outer little edge there. Okay? All right, so that's our intro, and now we'll get a little bit more math related with a different diagram to demonstrate this. Okay, here we go. Copy this into your notes. You should have this whole real numbers diagram. We call it a Venn diagram, where we can see overlapping ideas here. All right, and the idea here is that, let's say I give the number, let's take the number 4, for example. It is in the natural number circle, which means it's also in the whole number circle, which means it's also in the integer circle, which means it's also in the rational numbers box. Okay? Now, you will be trying to classify, and you have to give all the appropriate names that each number has. Okay? Now, over here, we have irrational numbers. And those guys are in a whole crew by themselves. They're real numbers. They are real numbers. But they're nothing else. They can't be whole. They can't be natural. They can't be rational. Okay? So they're there all by themselves over on the other side. All right, let's give it a shot. Here we go. Name all sets of numbers to which the real numbers belong. So this is our first example. We have 0.2525. Looks like it's repeating, which means I can write it as a fraction. And so if I go over here, I see another repeating decimal out here. So that would be just rational. We could call it a real number too, but the important one to get is that that's going to be rational. All right? If it ends in a repeating pattern, it is rational because you can write it as a fraction. Remember our rule there? Put the repeating decimals over that many nines. Let's get another example here. Ooh, 090909. Looks like it repeats. So I can put 9 over 99, which would simplify down to 1/11. Let's check it out. Okay, oops. Okay. There you have it. Now, going on to another example. Name all sets of numbers to which the real number belongs. We have square root of 36. So it looks like, that looks like a perfect square to me. So because this actually equals 6, this is what we'll pay attention to when we classify it. All right, the simplified version of it. All right, so where would 6 fall? Where would you shoot it in the goal? In that smallest goal, right? Wouldn't we put number 6 in here? So then it's a natural number, which is also in the whole number circle and also in the natural number circle, also in the rational numbers box. So let's classify. Since it simplifies to 6, it's natural, whole, integer, rational. Boom. Another example, name all sets of numbers to which square root of 25 belongs. Can I simplify it? Yes, I can. It equals 5, and that's a very similar situation as last time. So that goes in that central area of natural numbers. So it's all 4 of those. All right. Name all sets of number to which the real number belongs. All right. So that is a square root of 7. And I notice 7 is not a perfect square. So therefore, I am going to be using I could use my calculator. All right, we're going to be using calculators in this lesson to get some of the not perfect square roots. All right, so you can use your calculator there, but I know anything that's not a perfect square that I take a square root of is going to be irrational because it gets me a weird decimal that doesn't repeat and doesn't terminate. All right, so when we type it into our calculator, which I will teach you how to do, you get this long number that doesn't repeat and does not terminate. So it's irrational. All right, so you can write this example down and make sure that you show that since it doesn't terminate or repeat, we put it in the irrational category. Okay. As soon as I realize that this is not a perfect square, I'm taking the square root of something that's not a perfect square. I can immediately assume that that's going to be irrational. All right, if we typed it in the calculator, it would give us some weird answer. Okay, next we are going to fill in less than, greater than, or equal to make it true. So we have to put them into the same format here, the same notation. So the easiest thing to do is to put it into decimal form. And that goes back to our essential question. Why is it important to be able to write things in different forms? Well, so we can compare them. All right. So comparing numbers is much easier if they're in the same form. Now I'm going to cheat and go back to this problem here. Negative 2.645. So I like to write them vertically. Okay. 2 point, oh man, now I already forget it. 645, there we go. 645. I like to write them vertically and line up the decimals. So I can do my long division and realize that 2 2/3 is equal to 2 point, and then if I do 2 divided by 3, I get 6 repeating. But I want to put the same number of decimal places as my other problem so I can compare them more easily. So there we go. Now there's going to obviously be a lot more 6s, but I already see that at that last decimal place, which one is greater? Well, would you rather have 666 thousandths or 645 thousandths? I don't know if you're talking about parts of a cake. This is the greater one there. So that symbol is going to look like that. All right. So we write the originals here. We write the decimal form, lining up decimals, and using the same number of decimal places. All right, so you use as many decimal places as you need to make them to know if they match. So really, you only needed here 2 decimal places because look, after the first one, the 6 and the 6 match. So we got to go one further. So I look at the 4 and compare it to the 6. Well, I can already see that 6 is the greater one, so we can go with that. So we didn't actually need this final digit, but it's better to go further than necessary than to stop short and get it wrong. Okay? All right, so see how they line it up vertically and write the decimals. They wrote a lot of decimals, but we don't need that many. You only need as many as it takes to compare. Okay? Here is a nice little version of what it would look like on a number line. All right, that's a very zoomed in number line because look, you have 0.6 and 0.7. So you're looking at a very tiny range there. Okay. All right, so if we look at another example, try this one on your own. Okay, you can actually type in Google square root of 15 and it will give you the answer. All right, so try that one. And then,
according to Square Root, the square root of 15 with 1-digit decimal accuracy is 3.8.
it actually heard me while I was doing my notes. Did you hear that? That's funny. All right. So let's try this. All right, so I like to write them vertically, one above the other, so then my decimals can be lined up. All right, so let's go. Square root of 15 is approximately, I should put approximately, this doesn't terminate and doesn't repeat, so 3.872988. All right, I probably don't need that many, but it keeps going. All right, and then I'm going to get, this is going to be 3, and 7 divided by 8 gives me 875. Okay, my decimals are lined up. And now these match, so I need one more decimal place to realize that. Okay, here is the greater one. 5 is greater than 2. So we know that this is the greater one, so the alligator chomps up that because it's hungry. It's hungry. All right. Good stuff. Our answer should be that way. We got it right. Let's go. Okay. Fill in to see which one is greater. All right, let's put them vertically, 15.7% and square root of 0.02. Now, 15.7%, remember for percents, we simply move it over 1, 2 places because it means out of 100. And if we divide by 100, it makes the place value move over 2 places. So that would be 0.157. Now I'm going to do the square root of 0.02. Square root Okay, square root 0.02 equals 0.141, and it keeps going. But I noticed that those match, but those do not. So this is the greater one. So I'm going to point it in that direction there. All right, moving on. On the number line, ooh, I like how they wrote that number line there. I want to copy that. Number lines with decimals can be a little confusing. All right, good stuff. Okay, try this one on your own, pause, and then check your answer. Remember, you can Google square roots. Okay, it becomes greater than. Let's keep moving on. Hey, okay, I'll just do one example quickly of this. We're going least to greatest. So we are going to put them all vertically first, 6, 5 4/5, and 5.36 repeating. All right, now we're going to get all of their decimal equivalents. All right, square root 30 is going to be 5.4772. I don't think we're going to need to go any further. This is just 6. Now I'm going to give it the same amount of decimals, so 0.0000. And 5 point, right? You can do 4 divided by 5, or you can do 4/5 equals how many tenths? Oops, how many tenths? Times 2 times 2, so that's 8 tenths, so that's 0.8000, just to keep it going. And then this would be 5.3, and only the 6 repeats, so that's going to be 6, 6, 6, dot, 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 dun, dun, dun. Good Halloween number there. Okay, so we're going least to greatest. A lot of times I'll just put the least, I'll give it these, since there's 4 numbers, I'll just label them 1, 2, 3, and 4. And this being the least, right? And the 4 being the greatest. So which is the smallest number? Okay, well, let's see. I know the greatest one is the 6, right? That's easy. So I'll give that the 4. That's going to go last in my list. All right, now we can check this second decimal place. This one's out. We already know that, what place that gets. Okay, and that makes it pretty obvious there in that second decimal place. We got the 3 is going to be least, the 4 is going to be second least, the 8 is going to be third least. Whoops. And now we're going to write them in order of their original format. We don't want to write them in this format. We want to write them in this format here. So what's first? 5.36 repeating. Next would be square root of 30. Next would be 5 4/5. And finally, 6. And that is our answer, least to greatest. Okay, so write the original format of the numbers vertically, give the decimal equivalents, and then line up their decimal places so you can compare them one place value at a time. All right, we got it right. How about that? Okay, practice this one. Oh, I already gave you the answer to that one. Okay, so you already have the answer there. Don't worry about practicing it, but it should be pretty simple, especially since you have a calculator. Okay, so we've done a good job here. You can try this as well. Write one example of each of the following: a whole number, an integer that is not a whole number, a rational number that is not an integer, and an irrational number. Thanks so much for listening. Great job. Have a terrific day.